Hello, this is Andy from Filmlight. Today we will have a look at the ACES workflow within Baselight. We will start with the scene setup, import different kinds of footage, apply CDL values, fix out-of-gamut colors, and we will finish with a visual effects round trip. ACES stands for Academy Color Encoding System. It is a very popular color management system in the motion picture industry developed by the Academy of Motion Picture Arts and Sciences. In an ACES pipeline, all different input sources are converted into one common scene-referred working color space. The working color space for grading is called ACES CCT. It has a log transfer function and AP1 color primaries. In the grading stack, optional look modification transforms, LMTs, can be applied via LUTs or formulas. In the output path, the reference rendering transform, RRT, converts the graded scene-referred image for the selected display. Okay, let's create a new Baselight scene. You need to select the ACES scene template in the new scene dialog. That's it. You will now work in an ACES compliant environment. The important settings are that the working color space is set to ACES CCT, grade result color space to from stack, and the display rendering transform to the ACES RRT. The ACES RRT is available as a display rendering transform family, which means it supports several viewing conditions, which make it compatible with HDR. Also, please note that the ACES RRT is automatically selecting a sensible mastering color space for each viewing condition. So I recommend that you leave the mastering color space on automatic from DRT. The ACES scene template does bring a couple of render presets. For example, for dailies, visual effects plates, and a couple of common deliveries for SDR and HDR. Let's put some footage to the timeline. I have a couple of raw shots here and also some graphics. Okay, let's step through them one by one. The first one is an XOCN shot from the Sony Venice. We can see that Baselight decodes it to Sony Linear S-Gamut 3 color space and then to ACES CCT as a working color space. From there, the ACES RRT display rendering transform converts it to 2.4 gamma 709. The next shot is an Arri RAW shot. Here the only difference is that the decode is performed in Arri Linear White Gamut. This is a red raw shot, which is decoded to red linear, red white gamut RGB. This is a rendered ACES OpenEXR file, and we can see that Baselight automatically detected ACES linear AP0 as the input color space from the metadata. If you're dealing with ACES EXR files with incorrect file metadata, you might need to select ACES linear AP0 here manually as the input color space. This is a Cineon file from a film scanner. Baselight was not able to set the correct input color space based on the metadata. That's why it is falling back to unknown and then uses the stack color space, which is ACES CCT in this case. This is clearly wrong. The image looks way too saturated and too contrasty. Here we can select ACES ADXlog as the input color space. This is what the Academy proposes as an input color space for film scans. In Baselight, you have an additional option, which is a generic Cineon printing density log color space as an input, which might give better results if the scanner was calibrated to Cineon standard instead of ADX. So far, all the input sources were scene-referred. They had the small camera icon here and came from the scene-referred group of color spaces. But sometimes you also have to deal with display-referred input color spaces. For example, in this case, I have a logo inserted into my timeline. Here, Baselight detected a 2.6 gamma and P3 D65 color space from the metadata of the file. Because this is a display referred input color space, Baselight needs to apply the inverse DRT on the input side to convert the clip to ACES CCT. It shows a hint about this in the color space journey. Here is another clip with some graphics, which is imported as 2.4 gamma Rec 709, a standard HD video file. Here we also apply the inverse RRT on the input side to bring the clip to ACES CCT. Like in all other scenarios, please always set the correct input color space for your footage. If the metadata is wrong or the clip is tagged as unknown, please choose the right input color space manually. In ACES pipelines, it is common to share looks with other departments like dailies or visual effects via CDL files. For these shots in the timeline, I received grading data via CDL. To apply it, I go to the Multipaste tool, select CDL CCC XML files, browse to the correct folder, and then select the shots I want to apply it to. In my case, I select all the shots in the timeline and hit Multipaste. Baselight now added a layer to every shot with the CDL operator and the correct values in them. When dealing with CDL grades, it's crucial to know in which color space the CDL grade should be applied. Here I assumed ACES CCT, my working color space. To export CDL grades from a timeline, go to Shots View and use the function Export CDLs from the cogwheel menu. While working in ACES, you might have to deal with out-of-gamut colors. These are highly saturated colors that are outside of the working color space, in this case, outside of AP1 color primaries. Here's an example of an ARRI camera that recorded an extremely saturated blue color value around here. When we try to solve it by using a classic saturation algorithm, we can see we run into black artifacts. The same happens if we try to desaturate just the blue in the hue shift. What is happening here? Let's create a new cursor that I will set to the working color space. An important note, never use a cursor like this for the real color grading. We only do this now to examine the pixels in more detail. We can see that the code values down here are going into the negative ranges for the red and the green channel. The same can be witnessed here in the RGB parade, that the red and the green channel are clipping in the blacks for these code values. These values are lying beyond the blue color primary. We can't describe their position by adding more blue. That would only make them brighter on the blue color primary. To move them beyond, we need to add negative red and green to the color values. And some algorithms are not dealing well with negative numbers coming in. Let's go back to our normal cursor and see how we can deal with that. The first option is to add a look operator and selecting the M401 blue light artifact fix. This is a custom color matrix shipped by the Academy for dealing with these situations. It basically remaps the blue color primary, which works really well for removing the out-of-gamut colors. But by remapping the color primary, we also affect a lot of other colors in the image. Here you can see a before and after of adding that fix to a typical image. So this fix will also affect your overall look. An alternative is using the compress gamut operator. Here we select the target gamut where we want to compress to and then move the chroma threshold slider over. This tool just smoothly bends in the out-of-gamut colors. After applying it, the negative color pixels are gone. Then we can just apply our used tools to deal with the problem. For example, here using Hue Shift. We can also see that applying the compress gamut fix to a normal image does not change the overall look. Both methods are working fine. Choose whichever method fits better in your scenario. Let's see how we can apply a LUT-based look modification transform, short LMT, in Baselight. One option would be to use the TrueLight or LUT operator, but today I want to show you how to put a custom LMT into the look operator inside Baselight. The important thing about the look operator is that the input and output color space of the look must be identical. I got provided with this Film03 cube file as the LMT. It should be applied in ACES CCT. The only thing I need to do is create an FL look file that points to the cube. This is the file name of the cube. Here I define the color space in which the look should be applied in, and the rest is how the look appears in the user interface. I assumed a new looks group called ACES LMT for this look. That is why I created a new FL look group file that defines this new group. What I now need to do is put these files into my looks directory in Baselight. On the Mac, this is library, application support, FilmLight looks. On Linux, this is USR, FL looks. Now going back to Baselight, look operator, I need to hit the refresh button, and we can see we have a new item here, ACES LMTs, and inside is my Film03 LMT, which gives me the desired look change. In this case, it's quite subtle on the image. This is a neat way to organize a huge amount of LMTs. How does collaboration with visual effects work? Ideally, all graphics are produced scene referred and are provided for the final mastering in linear AP0 color space as OpenEXR files. This is also called ACES 2065-1. If some assets are only available in display referred, like 2.4 gamma Rec 709, then we need to apply the inverse RRT to bring it into our scene referred working color space. Plates in an ACES pipeline should be rendered also to linear AP0 OpenEXR files and are then provided back from the visual effects team in the same color space. Linear AP0 is the only color space ACES files should be exchanged in. So when you receive a file that is tagged as ACES, you should assume it is linear and has AP0 color primaries. To optimize the behavior of tools, the visual effects team might convert the images into linear AP1 color space, which is also called ACES CG, inside their software. Let's prepare and export some shots for visual effects. I have 3 ARRI shots in my timeline. The first thing I suggest is putting a compress gamut operator on the shots. The visual effects operators will probably work in AP1 color gamut, and their tools might be disturbed by negative code values. That's why I set the target gamut here to stack color space, which is AP1 from the ACES CCT color space, and then I'm setting the chroma threshold roughly to 0.1. This will get rid of all the code values outside of AP1, but note this is not a hard clip, this is a smooth bend in, so no information will be lost. And this is to clean the shots from extreme color values. It is more a technical process, and we can see that on most shots it has visually no impact. The next step is to apply a basic color balance and exposure correction to every shot. I suggest using base grade for this. If you restrict your toolset only to balance and flare, you maintain the scene linearity of all the shots. In this case, I might lower a little bit the exposure and adjust the white balance. To match the other shots, I might try the pick and match. Picking here, match here. I might need to adjust a little bit the exposure. And match here. On this shot, I might lower also a little bit the exposure and also the flare value. Note that adjusting the balance in base grade is similar to changing the white balance in the debayer settings of a RAW shot. Okay, now let's render the shots. I open the render panel and I will use the Visual Effects Blades graded template. All these templates here come from the scene template as mentioned before. ACES visual effect shots should always be rendered to OpenEXR and to ACES linear AP0 color space. Please note, don't render ACES CCT or even worse, ACES CC into DPX files. I want Baselight to automatically create folders with the event number and the input strip name in it. In this case, for the first shot 001, shot A. Every shot should start numbering at 1000. That is why I put F-E plus 1000 in the expression numbering field. We're good to go. Let's render the shots. Okay, done. Let's put them into the timeline. Here they are. Let's compare to the reference. We can see it's a perfect match. Note that in this case, Baselight was able to pick up the correct input color space of the EXRs automatically as ACES linear AP0, because the Baselight renderer wrote the right metadata into the files. If you're receiving the shots back with incorrect metadata or missing input metadata, you might need to manually tag them as ACES linear AP0 on input. You could automate this easily with media import rules inside Baselight. Okay, that's it for today. See you next time.